All right, here we go again. Are we having fun yet? More AP Chem question number 4 reactions. Again, you're given a description of a reaction. Your job is to write the balanced equation, removing any spectators, balance it, and then answer a question about that reaction. Okay, so here we go. A solution of copper 2 chloride is added to a solution of sodium sulfide. So what do we have? I've got two ionic compounds, copper 2 chloride. Again, that Roman numeral 2 is telling me the charge on the copper is +2, so therefore I need 2 chlorides. Since each chloride is -1, do not miss this simple stuff. Formulas of ionic compounds. Added to a solution of sodium sulfide. Sodium sulfide, sodium is going to be +1. Sulfide, look at your periodic table, -2. There are two ionic compounds. Okay, so we're working outside the box right now. Now we're going to go into the box because only what's in the box is what's graded. You'll have room on the test for outside work, but your work has to go inside the box. So copper +2 chloride is going to be a spectator here, okay? Is going to react with what? Who else is going to be a spectator? Sodium is going to be a spectator. So sulfide is going to be an active ingredient. Sodium ion is a spectator. So there are our two ions. Again, precipitation reaction. They're going to produce copper 2 sulfide. All right, everybody good? Name the spectator ions here. This is a good one. You hope you see one that's simple on the test. Sodium is a spectator. Chloride is a spectator. Bang. Boom. Great shape. That precipitation reaction, double displacement reaction, whatever you want to call it. Sulfides are generally insoluble unless, of course, your cation is one of the group 1s or ammonium. Again, remembering those precipitation rules. So pay attention to when you have two ionic compounds mixed together. Always a combination, almost always a situation where we can pull off the double displacement reaction. Ions just switch places and we're forming a precipitate. Speaking of which, take a look at the next one. Solutions of manganese sulfate and ammonium sulfide are mixed. Manganese sulfate, okay. Ammonium sulfide, again, I'm hoping that you look at this and say, I know the sulfate's going to be a spectator. I know the ammonium is going to be a spectator. This is another example of a precipitation, double displacement reaction. Manganese, because it's manganese 2, it's going to be +2. Again, we've got our friend sulfide. The only difference is it's ammonium sulfide now, not sodium sulfide. It's still sulfide. Ammonium ion is going to be a spectator. Guess what? They get together and form manganese 2 sulfide. List any precipitate that forms in the reaction. The precipitate is going to be MnS, and again, its name is manganese 2. Again, use those Roman numerals with the transition metals. Sulfide. Bingo. Wow. All right. Another straightforward, easy one. Super. All right. Onward. Notice the similarities between these first three reactions. Now, letter S here. Solutions of silver nitrate and sodium chromate are mixed. All right. So again, we've got solutions of two ionic compounds. Silver nitrate, nitrate, almost always a spectator. So I'm just going to write that as silver plus. Again, remember, silver is one of those transition metals that's always +1. So unfortunately, we don't use the Roman numeral there. We expect Roman numeral 1. We expect that you know that silver will be +1. Silver reacts with chromate. All right, chromate. Got to know your polyatomic ions. Chromate is CrO4 with a -2 charge. So there's chromate. Again, sodium is going to be a spectator. What kind of reaction? Another example of a precipitation reaction. Silver chromate, I'm going to need 2 silver ions to get together with 1 chromate. So silver chromate is going to be Ag2CrO4. Are we good? Another precipitation reaction. Chromates are generally insoluble, unless, of course, they're combined with group 1 or ammonium. Another precipitation reaction. What is the oxidation number of chromium in chromate? All right, so chromate. Write it again here. CrO4 with a -2. Let me change color here. Do a little bit of review of oxidation numbers. Oxygen, -2. Reference point, 4 oxygens give me a -8. Therefore, chromium must have an oxidation number of +6. So oxidation number of chromium equals +6. Bingo. We're good with that? Want me to go back to the blue? Sure. Okay. Lastly, glacial acetic acid. Glacial. Weird name. It's just another way of saying concentrated acetic acid. So, got to be able to write that formula. C2H3O2. Acetic acid is a carboxylic acid. Okay. With methanol, C3OH, our simplest alcohol. Okay. Acids and alcohols get together to form esters. Okay. And so we're going to get an ester formed here. So I'm going to have my CH3, my C double bond O from the acid connecting together with the methanol. Okay. And I'm also going to kick out a water molecule. So a little bit of organic chemistry here. Acids react together with alcohols to form esters. Again, remember, esters tend to be sweet-smelling compounds. Okay? Notice what makes an ester is that carbon-oxygen double bond connected to an oxygen connected to a carbon. Oh, what type of organic reaction is this? This is an esterification. Ester formation. Okay? Acids, carboxylic acids, and organic and alcohols combine to form esters. All right, we've got 4 more done. We're working through these.